Okay, hi. We start this lesson. This section focuses on Docker's containers. In fact, there are many cloud platforms, like Amazon, like Alibaba Cloud. There is a container service similar to this. Usually it is to put some mirror images. Put it in a container. You can run it directly. This is an I/O service. It's over here. This is the document. Relatively speaking, it's easier. Just give a mirror image. The general mirror image can be found here. Docker Hub. Of course, you can also make some mirror images yourself. I made one for the course. Mainly do service testing, but the service of Ionet is very specific, mainly based on large-scale model services. Its mirror image. There are some basic requirements. Not all mirrors are available. So let's start with this. It must support CUDA. It must be, because we are making GPUs. The image needs to support CUDA 12.8 or above. We recommend. It is based on this official image of NVIDIA. It is equivalent to your image with Ubuntu. If you want to do some of your own services, you have to build your own development environment. Just use this mirror image to put things inside. This process is already relatively mature. Second point, we should pay attention. Only one port is currently open. If you have more ports, you may not be able to use this service, or make yourself a routing map. This is a little more complicated. Third, what are the most commonly used services for scaling up models? Is to provide RESTful and other external services to our trained model. Actually, Ionet. The main goal of this container service is also this. We do large-scale model service development. Velm is generally known. This is used more often. Ionet officials also recommend using this service. Just use this mirror image. This mirror image. Most server environments support it. But it also requires attention. If you want to do some training, study, etc., salary, maybe it would be more appropriate to use the VM we talked about earlier, especially those who want to practice some programming. This container service. Its positioning is mainly service deployment. Certainly, you can also do some of these other types of services. So let's start with this. We'll just demonstrate. This is also relatively simple. This is a mirror image we made ourselves. This is a Hello World example. The mirror image has no special settings here. It is based on an original image of NVIDIA, simply made a Flask service. Let's take a look. This port is the default. In fact, this is what it says. You can test it. Run. Take a test. Let me show you the deployment again. Here it is. We require that it is generally the official image of Docker. You can also make some yourself. If it is private, you may have to write some token. That's okay. In addition, many images require startup commands. This mirror is unnecessary. There are also some such environment variables that are not required. This is mainly a basic test. Learning-oriented. Just write this. And then Choose this cheap one. 4090 is enough, because it is a test use. Just pay attention here. We choose 1 hour. Because I applied for some credit. About $0.5 for an hour. This is okay. Of course, you can also use other payment methods. For example, traditional payments such as Visa card can also be used. USDC can also. Just some credit applied for. Or pre-recharged. Then we deploy. Click like this to deduct the money. Pay attention. It is expressed in hours. You run for less than an hour and it's counted as an hour. Deployment usually completes in less than 5 minutes. Wait a minute. All right, let's take a look. It starts like this. Most of the time is spent downloading the images. It may take a few minutes. That's it. Also, what do you think of the service? Take a look. Yes. This is my public URL. Click. And let's take a look. It's okay to see hello. This is a basic service. Let's take a look at how I do this service. It's actually composed of Docker. There are only 3 files in it. Docker file. It is based on this NVIDIA 13.0. Then install a Flask on the pipe. It's basically the same. And then, this is the launch command. What about the requirements? Install Flask. This is a simple service. Then create. Just upload it to Docker Hub. If this is not clear, just learn a little Docker command. So here's the image that I created. Here is the mirror you uploaded. And then, that is to say, if I want to be a Jupyter service myself, I just want to build one myself. Requires some additional configuration. For example, the transformer version I use is different. If you use the official, it may all have to be reinstalled. It may take a few hours to install. It would be much more convenient if you put it in the mirror image in advance. Typical scene. I'm going to take a course. Let's make a mirror image for everyone. You can use this mirror container service. There are many such scenarios, especially for what we learn, or do some science experiments. Encapsulate the environment. Upload to Docker Hub. Then it's ready to use. Especially your environment has more things. Just do it all at once with a mirror image. Let's take a look. This is the mirror image of my installed Jupyter. The process is the same as in the previous example. Everybody pay attention. Why is the port 88,888 here? Because the default startup port on the Jupyter side is 8888. So write this right. The first example is 8000. Everybody pay attention to this. 8000 corresponds to this. It is also the default 8000 on the official page. Let me show you this. This is also a more commonly used one. I'll create another one. Just write the mirror name. And notice this. The service is only one port. Usually enough. The default is this port, if not changed. The external port of the mirror should be changed to this. Ionet actually forwarded this port to the external AD. Okay, so this must be written. There is no need to write the start command, because I have already written in the mirror image. This is also a 4090. Take another look. This doesn't need to be set up either. And notice that. Just choose 1 hour. Then payment. That's it. Wait a few more minutes. Let me show you. After completion. That's it. Sometimes it may take extra time for the service to start. To show start, you can take a look first. This is the link. Just copy it and open it. This is already okay. The password is preset by me. I set 88,888,888. Of course, you can set it yourself here. Just order it when you make the mirror image yourself. That's it. And then, I will briefly test the service, mainly to test the operating environment. See if it works normally. Generally the most common. Take a look at the number of GPUs. Also, see if CUDA is correct. And then the GPU model. Take a look and it's okay. CUDA. The GPU used is 4090. Explain that there is no problem. Let's take a look again. Create file. Pay attention. We install this torch. It is necessary to write this configuration. Otherwise, it may install the CPU version. Such a template. It's all the same. Those are the requirements. Then Docker. These configurations are similar. With this environment, a relatively new environment, these are all the same. The requirements are what we wrote above. This is the default server level port. This is your password. You can fill it out yourself, if not set. You don't know what the system default password is. This is the port. Default port. 8888. That's okay. This template is very useful. Like our course. In the future, a mirror of the environment configuration will be made for everyone. Container services for I/O. Fill in the mirror name, and that's it. And then, let's look at a more in-depth example. Third, this is actually the most important thing for us. It's how you train a big model on yourself to provide services to the outside world. It is best to be compatible with the CDAK of OpenAI. Students who do similar large-scale model development may know. What are the most commonly used frameworks? That's Velm, an open-source large-scale model service framework. And you can look at one of its documents. Most of the models on Hugging Face. You only need to specify the name of a model, confirm the parameters and path. Velm will give a service compatible with OpenAI CDAK. Of course, there is also a RESTful interface. This is its homepage. You can take a look. It is also very convenient to use. We're actually using the Docker version of it, because we are now using container services. Velm-related documentation. You can take a look for yourself when you have time. Most cloud platforms are supported. Ionet definitely supports it too. This mirror deployment may be a bit more complex. Let's take a look. So let's start with this. Try to use this version, because this version is recommended by IO, because this is relatively new at the moment, also relatively stable. The latest version may be updated a bit. It's just that the startup command is slightly different. Let's take a look. Here it is. It comes in many versions. We use 10.03. There is now a relatively new version 11. The previous version we used, mainly stable. This is version 10.2. And then there is another one on the command line. Why not fix the start command? Because we want to define parameters, different large models, the parameters of the service and also the model name. This is the name of the model. Model memory utilization. These things may have to be defined by themselves. At least the model name is to be defined. So, it starts the service by starting the command. Let's take a look. The default port of Velm is also 8000, so this doesn't need to be changed. Let's start one and take a look. Note the mirror version number. Then start the command. Start the command. Let's take a look. The core is the model name parameter. Everything else is about the same. Just change the name of your model. The 1000 questions we use. Certainly, this model can be changed by yourself, as long as it's hugging faces. Then your video memory is large enough. Everything else is about the same. These don't need to be changed. Then add a variable. Mainly because our service cannot be stuck. Usually there's a timeout. All services should have such a setting. There is a timeout time limit. Just set this up. That's all. Take another look. This is our mirror image. Just a mirror image of Velm, right? Second point, start command, mainly to define the name of this model. Hugging Face large models can basically be used. One more, order a port, because Velm defaults to 000, so don't change it. Set a timeout time. Because large models generally require more video memory. To demonstrate is with H100. If the model is relatively small, can you judge how much video memory? 4090 can be used. We use H100 here. Everything else is the same. Of course, H100 will be slightly more expensive. Even more expensive than 4090. Compared to Amazon, these are still much cheaper. Amazon's now about $10. The discounted bidding is also $7 or $8. This is basically a few dollars. Select time 1 hour. Then pay and wait. Take a look at this. No Docker composed. No construction file. Because this uses the official mirror of Velm. Then wait a minute. Start. In addition, let's take a look at the models it supports. In theory, Hugging Face. Everyone can support what is common. Mainly video memory. You may have to estimate for yourself. Generally speaking, 7 Bs. 16-bit compressed. Generally, 4090 is enough. But if it exceeds 8B, like a 10 plus B, especially 50 or 60B, maybe H100. Everyone has to estimate. If it exceeds, the service cannot be started and an error will be reported. Pay a little attention to this. After it starts up, we can use it to be compatible with OpenAI's API. We can just use it. Just get a base URL. Just take this. Take a look. This is the public URL. Just put it in here. Generally, you will know after doing this large model project. This feature is very useful. Ionet's container service. Velm has been optimized and encapsulated. We can just use the SDK. Of course, this needs to be consistent with the above. Just a quick question. You can take a look. It must be this, followed by V1. Because there may be different versions later. This key can be empty. Let's take a look. We actually spent a few minutes. You can deploy a large model service. You can also deploy a large model you wrote yourself. Let's take a look. Because Velm basically supports large models of all transformer architectures. This is a large model of Llama that I trained myself. Just change this. Everything else is exactly the same as above. Then call. Because this is a genetic model, Biological sequence. The input is the protein sequence. Output 2. This is relatively simple. You can test it yourself. Just use this mirror. Change the model name in the startup parameters. This is the model in some papers I did myself. Did some continuous pre-training with llama. Belongs to the standard model. This is 7B. It is also possible to use 4090. When the maximum length is a little more, the video memory may explode. If you deploy a large model service with Velm, try to use H100, unless you are very sure about the size of your model. Test this for yourself. There are a few important points that need your attention. First, estimated memory. Generally speaking, it's like the 7B model. Video memory generally needs 3 times. That is, it needs 21 grams. 4090 is exactly 24 grams. If there is other occupation, it may not be able to run. The I/O system will show that the mirror has exited. Because there is no memory, it will exit as soon as it is called. Another of the most common questions. If the CUDA version is incorrect, it will also report an error. So it must be greater than 12.8. Because it is smaller than this version, many models on Hugging Face are not supported. That's it for the class.